said last week, when you're studying for your midterm, which isn't that far away anymore, these are things I want you to review. And if there's something in there like you're not sure about all the salivary proteins and their functions, then go back to the PowerPoint, remember the lecture, what the things that I said, but make sure you know all about saliva proteins and their functions, how they affect caries, and all that kind of stuff. So if you're not sure what arginine does, then just use this as a review. So the questions that I ask are not going to be what is arginine. It's going to be a little more involved than that. So when you're studying off of the objectives, these are not the questions. These are just the subjects. So just make sure you know these subjects. Okay. So why? Saliva is such. It gets on your mirror. It just gets in the way. You can't see the tooth. It's a real pain in the neck. But we need it because if you've ever, how many of you have ever had a patient who has xerostomia? Okay, so you know that it's even worse when you don't have saliva, because then everything sticks to your mirror and you can't get it off of their cheek, or their mouth is so dry that just opening it hurts, and you can't even get in there to prophy or much less scale. So saliva is excellent for lubrication. It helps with digestion. I don't know how many of you have ever tried eating something when your mouth is just really, really, really dry, but you just chew and you chew and you chew and nothing happens, and you just chew in and saliva is super important for swallowing and digestion. Your xerostomach patients probably, maybe they told you that they can't taste anything, because saliva is really important for taste. Or I don't even know what's worse. Sometimes when you don't have enough saliva, you taste something, but it all just tastes like metal. So everything tastes like metal. So your xerostomach patients are going to tell you that they don't enjoy eating, not only because they have to chew forever and they can't swallow their food, but they can't taste their favorite foods anymore. Okay, obviously we like saliva because it maintains the integrity of the tissues in the mouth, the teeth, the tongue, the cheeks. It just hurts to look when you see a patient that doesn't have saliva and the buccal mucosa is just kind of peeling off of their cheeks. It just looks like it hurts, and and it does. It really does hurt a lot. Burns and stings. So saliva is important for maintaining all of the oral structures in the mouth, not just the teeth. Like we talked about last week, the saliva maintains a buffering aspect of the oral cavity. So it's rich in calcium and phosphate and other buffering agents, and it keeps the pH in the mouth from shifting dramatically, or it should. So you all have had anatomy.
Yes.
So you know where the three major salivary glands are, but mostly they're just the three glands, the parotid, the sublingual, and the submandibular salivary glands. These glands each have little ducts that bring the saliva into the mouth, and these ducts will alter the content of the saliva as well. each of these salivary glands are composed of different cells. And so the different cells make different kinds of saliva. The ducts, between the length and the kind of cells that are in the duct themselves, that also alters the saliva. So you get different types of saliva from the different glands in the mouth. Let's go back. So your parotid, gland and duct is going to have it makes not too much of your non-stimulated saliva. So for those of you who missed the buffet on the way in, your saliva is about 10% of coming from the salivary, the parotid gland, because it provides about 10% of the saliva for just your resting saliva. And the same with the sublingual gland. It doesn't contribute too much to the resting saliva, maybe about 5%. So for those of you who did get the free meal, most of your saliva right now is coming from the submandibular gland. So about 60% of your saliva is coming from the submandibular gland. So each of these has its own specific duct. You've all seen the Stenson's duct. It looks like a little tissue tag stuck to the inside of the cheek. So that's the duct associated with the parotid gland. The parotid gland has mostly serous cells in it. So you're going to get mostly serous type saliva from your parotid gland. The submandibular gland has the Warthin's duct, and that's the one where, well, actually the submandibular gland and the sublingual gland kind of share the Warthin's duct. The sublingual gland first comes through the Bartholin's duct, and then it joins the sublingual duct. So that's the one that when your patient opens up wide and they just squirt out at you, that's the those are coming from the sublingual and the submandibular glands. Your sublingual gland is mostly, well, it's a mix of both serous and mucus duct cells. So you're going to get a mixed saliva from the sublingual gland. The submandibular gland is also a mixed gland, so you're going to get a mixture of saliva from those, both mucus and serous. Okay, your minor salivary glands are pretty much just everywhere else in the mouth. You don't get so much on the body of the tongue, mostly on the tip of the tongue and the back of the tongue, but everywhere else has little tiny minor salivary glands just in the tissue. Lots of times, like if you wipe the palate with a 2x2 and then look at it, you can see little beads of saliva start to come out from the palate. Okay. Each of these areas has different types of saliva as well. The palate is mostly mucus. The back of the tongue is mostly serous. The inside of the lips is mostly, and the tip of the tongue is mostly mixed salivary glands. Okay. So we were talking about the different kinds of glands. If you look at them with a microscope, they look a little bit different from each other. If you squint really hard, the mucus gland looks a little more rectangular, whereas the serous gland looks a little more triangular. Sometimes that comes up on boards, but mostly it's the difference in what they produce that is important. Okay. So your serous secretions are going to be mostly protein, with some water in them, of course. You have some carbohydrates in there. and some zymogen granules, which are the precursors to the amylase, the enzyme that's used in digestion. Mucus cells are kind of just the opposite. So they're high in carbohydrates, low in proteins, and they have a substance that when mixed with water forms mucus. So the mucin is in the mucus secretions. Okay. But all of these ducts, they don't just make mucus or just serous, because as the saliva comes from the gland and through the duct, it's altered as it passes through the duct. You have both striated and excretory cells within the duct walls, and these allow for the exchange of ions between the blood and the saliva. So it alters the saliva as it goes through the duct before it even gets into the mouth. Okay, your glands that have longer ducts obviously are exposed to these changes for a longer period of time, so they're going to have more changes in the saliva than maybe the sublingual gland, which has a shorter duct. Okay, but what this means is that you get a unique type of saliva from each gland. So when how much saliva is enough saliva? For a normal, healthy individual, you should make about 0.7 mils of saliva a minute, which is not too bad. But if you're making less than that, then your mouth is probably kind of dry. So right now I'm probably not making 0.7 mils of saliva a minute because I'm just talking and my mouth is kind of dry. But that's an important thing to note, because when your saliva production is not even throughout the day. It goes up and it goes down. Most people, their saliva production is at its lowest early in the morning, before you wake up, and then once you get up and start thinking about breakfast, then your saliva production jumps up, but it just goes up and down throughout the day. But on average, you should be making about 0.7 mils of saliva every minute. But what's more important, quantity or quality? So saliva is 99% water, but that's not the important part of the saliva. The important part of the saliva is the 1% of the saliva that isn't water. And in this 1% of saliva, you have all sorts of stuff. There's bacteria in the saliva. Like we learned last week, just because it's bacteria doesn't mean that it's bad for you. A lot of the bacteria, hopefully all of your bacteria are the healthy ones, and they're helping to protect you right now. But this is a good source of bacteria. There's a ton of minerals, well, maybe not a ton, but there's a significant part of the saliva that's minerals. So lots of phosphate, you have carbonate, you have bicarbonate in there, and these, like we learned last week, these help buffer the saliva against pH changes. And then there's the proteins in the saliva. You have the histatins and the stadherin and the sialin, the protein-rich proteins. You even have the immunoglobulins, the IgG and the IgA. These are all found in the saliva. So while it may only be 1% of the total volume of the saliva, this is the important part. You had a question?
Yeah, the 1%, is that the scientific terminology for it?
Super sauce?
Yeah.
No.
Okay.
It is what makes the saliva functional.
Is that a term that you use, or is that like a thing that we can say all the time?
Oh, when you're talking to me, or yeah, you can use super sauce if you want,
Sauce.
but mostly it's the if you're just talking to somebody, you would talk about the proteins or something like that. Yes.
So on like the midterm, is super sauce going to be on?
I don't think so. I'm going to be much more specific than super sauce on the midterm. Yeah.
Super sauce is pretty specific.
I think it ties it all kind of together.
But
Super sauce.
that's kind of the point. Is that this is, I mean, for your patients who don't make enough saliva, and they're always have a bottle of water with them or whatever, trying to make their mouth feel less dry. It doesn't help that much. Even though saliva is 99% water, just drinking water to replace your saliva doesn't really do the trick because it doesn't have any of the important things in it. So you're replacing 99% of what's missing, but you're not replacing the 1% that really makes a difference. So quantity is important because it acts as a diluting agent. It acts as a transport medium to bring stuff in, take stuff away. It provides the environment for the oral cavity, whereas quality of the saliva helps with the buffering of the pH of the oral environment. It brings in the antimicrobial properties, the immune factors. It acts as the substrate for the biofilm. So you can't really have one without the other. You have to have both. You have to have enough saliva to actually coat the mouth, coat the oral structures, and you have to have the right quality of saliva also. So if somebody asks you what's more important, it's like asking what came first, the chicken or the egg. You have to have both. You can't have one without the other. Like I said, if your patient's just drinking water, trying to replace their saliva, they're helping because they're providing a medium to wash away bacterial wastes and those kind of things, but they're not really bringing in any of the important things that are going to help with digestion, to buffer the oral environment or anything like that. So saliva is, besides the fact that saliva is really important for protecting your mouth against dental caries, saliva, because it when it's produced, it's in connection with the blood. It can give physicians kind of a window into what's going on in the body as well. And it's not nearly as invasive to get a sample of saliva as it is to get a little bit of blood. Just think about it. Would you rather have somebody wipe a swab on the inside of your cheek or stick a needle in your arm? It's just, one's a lot easier than the other. The problem is that if any of you spell oral like that, you're in big trouble.
Yeah, kind of agree to that.
He's from the south, it looks like. Anyway, sorry, I just got distracted. So they're developing more and more tests to analyze saliva, and they can get a lot of the same information from the saliva that they can get from the blood. So there's markers for genes, so they can do cancer screening with salivary analysis. They can do just about anything that you can check in the blood. They can check in the saliva. It's just developing yet, so it's not as common. But hopefully one of these days, when we go in to get our physicals done, they'll just have us spit into a cup rather than take a little bit of our blood. But for us, we're probably not going to be using it to find out so much about what's going on in the body in general, but it does tell us a lot about what's happening in the mouth. So we can test resting pH, we can test stimulated pH, we can measure how much saliva a person is making, we can check the buffering capacity of the saliva to see how well it resists pH change. We can check for specific salivary proteins. We can see what kind of bacteria are in the oral environment by testing the saliva, whether we test it for bacteria metabolites to see who's been there, or you can actually just take a sample of saliva and plate it out on a medium and then culture it and then count all the little colonies that grow as well. So we can learn a lot about what's going on in the oral environment by looking at the saliva. So some of the proteins that are in the saliva, you have the sialin, which is your main buffering protein. So this is the protein that helps maintain the pH balance in your mouth. The stadherin is a protein-rich protein, and it stabilizes inorganic ions like the calcium and the phosphate. And this helps to keep the saliva in a supersaturated state, so that there's plenty of calcium and phosphate to help with the remineralization of the teeth. Mucins, there's a bunch of different mucins, but in general, the mucins make the bacteria clump together. So instead of the bacteria attaching to the salivary pellicle, it attaches to the receptors on the mucins, and it just makes a little ball of the bacteria that gets washed away. Lysozyme, lactoferrin, and salivary peroxidase, they all work together as an antibacterial part of the saliva. So they tend to inhibit bacterial growth. So we went over the salivary peroxidase, antibacterial. The lactoperoxidase helps with altering the attachments of the bacteria to the tooth. So it's also a type of antibacterial. Okay. So more specifically, we'll talk a little bit more specifically about the sialin. But the sialin, some people call it the pH rise factor. But the sialin is a protein. It's a tetrapeptide, and it's composed of glycine, lysine, and arginine. So it's a tetrapeptide made up of these 4 amino acids. It's found mostly in the parotid saliva, and this tetrapeptide is a bacterial nutrient. Okay? And once this is metabolized by the bacteria, the metabolites that are left over are really basic. So the sialin is metabolized into urea, which then breaks down into carbon dioxide and ammonia. Okay? Is ammonia acidic or basic?
Basic.
Very basic, yeah. So when the bacteria metabolize the sialin, it tends to raise the pH. Okay. This this metabolic pathway that the bacteria use to metabolize this sialin is called the arginine deaminase system, and it just breaks down the sialin into ammonia, and which raises the pH in the oral environment. So this is why, we'll talk more about it later, but this is why arginine works so well in helping to prevent caries, because it's just part of this arginine deaminase system. So instead of having to break down the sialin, the bacteria are just fed the straight arginine, and then they break that down into ammonia. So it tends to raise the pH, which favors the non-karyogenic bacteria. Okay? So sialin, super important. Arginine, super important. Okay, stadherin, like I said before, is a protein-rich protein, a chromium-rich protein, and it binds calcium. So you can find it in the parotid and submandibular saliva. But this stadherin molecule inhibits precipitation of the calcium. So it keeps the calcium in solution so that it doesn't precipitate out as easily. So what it does functionally, for the reason we like it, is it acts as a reservoir of calcium, so that when the pH drops and they're looking, all those little hydroxyl ions are looking for a calcium or something to bind to, then you have an excess of calcium. So it serves as a reservoir. One of the secondary functions of the stadherin is it promotes the adhesion of the Actinomyces viscosus and the Streptococcus gordoni to the tooth surfaces. So from last week's lecture, are these one of the early colonizers of the tooth or one of the later colonizers? Or to make it easier, are these good guys or bad guys? Good guys. Yeah, these are the good guys. So this stadherin is one of the proteins that help in that early attachment of the pellicle to the tooth. Okay. So the other thing that this stadherin does, as hygienists, you should be kind of excited about this, but it inhibits the crystal growth of the calcium. So stadherin inhibits the production of calculus. So if you have enough stadherin, then it keeps the calcium in suspension instead of letting it build up on the tooth. It just makes our lives just that much more easy. Okay, mucins. These are high molecular weight glycoproteins. So while they're proteins, there's a lot of carbohydrates in them. So these glycoproteins have over 40% carbohydrate composition as well. There's a bunch of different mucins. The MG1 is mostly produced in the mandibular and sublingual glands, the submandibular and sublingual glands. The MG2 is associated mostly with mucosal integrity. So when I was talking to you about your patients where the inside of their cheek is just sloughing away because they don't have enough saliva, this is the part that they're missing, the MG2. But in general, the mucins tend to clump bacteria together. Specifically, the mucin 7 has been linked to caries. There's a test that was developed at at UCLA to actually test for mucin 7, and they were able to show that the absence of mucin 7 resulted in a higher caries rate for those individuals. The way that the mucins work, the key part to remember from mucins is that they tend to clump the bacteria together. So instead of binding to the tooth, they bind to the mucin and then they get washed away. The last three proteins or the next three proteins that we're going to talk about, they kind of all work together. So they've been called the three amigos, three musketeers, but they all work together in an antimicrobial fashion. So the lysozyme, lactoferrin, and peroxidase, these three work together to inhibit the bacteria in the mouth. So the lysozyme comes from the major and minor salivary glands. You can find it in gingival crevicular fluid. And everybody has it. As soon as a baby's born, they have lysozyme in their mouth. The way that it works is it tends to break down the cell walls of the bacteria. Gram-negative bacteria tend to be a little more resistant because they have that lipopolysaccharide layer on them. And the karyogenic bacteria are protected by the glucans and the mutans molecules as well. But that's where the other guys come in. The lactoferrin comes from the major and minor salivary glands as well. It's released by leukocytes into the gingival crevicular fluid. But it's inactivated in the presence of high iron. So in the iron-free state, you have apolilactoferrin, and the apoferrin binds irreversibly to the bacteria, which cause the bacteria to clump together, and then they get washed away by the saliva. It also interferes with the metabolism of the bacteria. By absorbing the iron, it keeps the bacteria from getting the iron they need. So this is the second of the antimicrobial proteins in the saliva. The peroxidase works in a couple of different ways. You have the salivary peroxidase from the major salivary glands, and then the myeloperoxidase found in the leukocytes. But these combine with the thiocyanate to form a hydrogen peroxide, and this hydrogen peroxide is the antimicrobial component to the peroxidase. This functions best at low pHs when there's and high levels of the thiocyanate. But this tends to break up those more resistant bacteria with the polysaccharides on the cell walls. So that's how it works together with the other two amigos. Okay. So the peroxidase tends to help protect the oral structures from the hydrogen peroxide. It works not only against the bacteria but also against fungi and viruses. In the presence of iodine, it's even more potent against the oral anaerobes. So some people have proposed iodine as an antimicrobial agent, but you have to be a little bit careful with iodine when you're just giving it to your patients, because anybody who's allergic to shellfish is going to have problems with iodine. And then you definitely don't want to give iodine to a patient who's pregnant, because it's going to interfere with the fetus as well. So, and besides the fact that when they gave the patients povidone iodine, it's not very, doesn't taste good at all. But it's very, very effective against oral anaerobes. So all those bacteria with the polysaccharide shell over the cell wall, this breaks them down really well. So the peroxidase was very effective against those. Okay. Then you get to the histatins. So histatins are most effective against fungi, and they help with wound healing, with wound closure. So they also tend to inhibit the matrix metalloproteinases. So if you remember back to our first lecture on the different theories of caries, with the dentinal fluid transport theory of caries, when there's not the dentinal fluid flowing through the tooth, it tends to set off an inflammatory response, and that's when the matrix metalloproteinases are activated as part of the inflammatory response, and they tend to start destroying the tooth surface. Well, the cystatin 5 helps to inhibit or to dampen down that response. So it helps to protect the teeth in that way as well. Dogs have a lot of histatins. That's why some people will tell you having a dog lick you is actually good for you, because they have a lot of histatins, and it helps with the wound closure.
Is that really true?
With my daughter's dog, I wouldn't recommend it because, well, you don't want to know what she eats, but it's disgusting. So yeah, you don't want any kisses from my daughter's dog. The thing is that there's while there is a lot of the statin 1s and 2s in the dog saliva, there's a bunch of other stuff also. We don't want to share all those other things. But they do have a lot of histatins. So. Okay, but that's why when they lick themselves, it helps with cleaning themselves. Okay, cystatins are not as well understood, but they do have a role in the modulation of the calcium levels. So they have kind of a similar function as the sialin, and to a smaller extent like the stadherin. So they help with the levels of the calcium in the saliva. Cystatins have been more closely studied in relationship to periodontal disease, and as the levels of cystatin are when you have periodontal disease, your levels of cystatin are going to change as well. But for caries, the way it affects caries is that it tends to bind to the calcium, and so it's similar to the stadherin in that respect. Okay, so the most numerous immunoglobulin in the saliva is the IgG. The IgA. I mixed that up. But the IgA tends to prevent bacterial adherence to the mucous membranes. So it tends to lower the stickiness of the bacteria. So it makes it easier to wash the bacteria away. Okay. So we've had a couple of really long lectures. So today we're going to have a short lecture. But just because the lecture was short, there's a lot of material in here. So you're going to want to go through it and review it because, yeah, just about everything in here is super important. So it's really condensed. So you're going to want to know this really well. Next week,
You want to have a quiz on this for the next week, right?
no. Next week, so the question was, are we going to be quizzed on this next week? No. The quiz next week, who has Canvas open to the modules?
I have a question about that. One of the articles is about 32 pages long. Are you requiring us to read all of it?
Just remind me what it was on the module for next week.
Carrie's risk assessment.
Yeah, Carrie's risk assessment. No, I'm going to make, so the question was, do we have to read all 32 pages of the article that I have for next week? And that's too much. So I'll send out an announcement, and all 32 pages of that article are important. There are some pages that are much more important than others, so I'll tell you where to concentrate. I do have access now to Canvas again, so I will send out an announcement to what you should really concentrate on those ones. So so when I read an article, I read it like because I'm really a clinician. I'm not a researcher. As you can tell, I'm not even really a lecturer. I'm a clinician, and so when I read an article, I read it mostly with the idea of how does this help me treat my patients. But you guys have had limited exposure to patients so far, so you don't have my exact bias on that. So I'm going to give you a kind of a heads up on how to focus on this article a little bit better. Okay. Okay. So in the first lecture, I said we're going to drop to the lowest score on the quizzes. So there's been a couple of you who've had a low score already. So I would recommend not getting another low score, because the next low score we're not going to drop. So you want to do well on your quizzes. But now you have a kind of an idea on how I ask questions, so maybe it'll be a little bit easier for you as well. Any other questions? Okay, that's a little bit worrisome for me. There's a ton of information that we went over this morning, so make sure you know it well. Okay, good. You guys are good to go.
Go ahead.
No, I was asking you.
No, next week will be a lecture.
Functional subjects.
We're meeting on the 23rd, right? For that class?
Yeah.
That's the first time we're gonna meet for that class?
Yeah, on Tuesday.
For period, right? I mean for
Orthodont.
ortho.
Yeah. Why, are you interested in ortho or? Oh, you're just.
Learn about first time. 3 weeks off and then
Yeah. Yeah. So we're coming back here at 2:30 for a career day. Are we required to come up? Oh, okay.